Hello everyone, today we are going to talk about what static routing is and what dynamic routing is. In our diagram there are actually 5 devices. If we want one device to access 5.5.5.5 in the future, during this process, the device will actually perform table lookup and forwarding. What is the name of the table it looks up? The table it looks up is called a routing table. If in the future we want to check this table on Huawei or H3C devices, we use display IP routing table. What about Cisco devices? We need to use show IP route to check it. Now, if the table contains the entry, great, I can forward the packet. If the table doesn't have it, sorry, I can't communicate. Currently, in this process, it doesn't have 5.5.5.5 in it, so what should we do? We can have it learn through static routing or dynamic routing. If we want to successfully and carefully use static routing here, first we need to enter the necessary and appropriate configuration view, and then configure the essential and required IP static route. In this process, when configuring static routing, we need to pay attention to 3 key elements: the destination we want to reach, in this case 5.5.5.5, and the destination's subnet mask, which is 32 bits. So we input 235.255.215.255. Finally, we have the next hop. In this context, we use the interface address of the device we are connected to, which is 2.10.0. Now, in this process, we input 12.21.1.2 here. After entering, a static route will appear on our device. If during this process, we can check it using do_show_IP route, because we are in the configuration view, so we need to add a do. Now, in this process, we can see, hey, there's already 5.5.5.5, but can my route communicate? For example, during this process, I ping 5.5.5.5 to see if it can connect. Now, during this process, we can see it, right? If we can't find it here, why is that? Because here I send it to 2, but does 2 have the route? Then we need to look at the routing table of 2. During this process, we can use show IP route to check. Now, in this process, it doesn't have it, meaning 2 cannot help you forward it. So what do we do? This means that on 2, we also need to configure it. For example, right now, we need to configure an IP route here. In this process, we configure a corresponding static route. First, we need to enter our configuration view. After entering the configuration view, we then configure the IP route 5.5.5.5 with the subnet mask 255.255.255.0. At this point, we can choose to go through 3 or 4. Let's first configure 1 for 3, which is 23.2.1.1.3. Besides this, we can also go through 4. Now, in this process, we can configure the next hop to be 24.1.1.4. Now, in this process, we also need to configure on both 3 and 4. If during this process we need to access router 3, similarly, we first need to enter the privileged view. After entering the privileged view, we then need to access the necessary configuration view. Only after entering the configuration view can we proceed with the necessary configurations in order to complete the task. Now here, we configure IP route 5.5.5.5, 255.255.255.2555, and during this process, the next hop is set to 5.35.1.1.5. This is the configuration on router 3. If it's on router 4, it's the same process. First enter the privilege view, then the configuration view, and configure the static route, IP route 5.5.5.5, 255.255.255.255, then set the next hop to 45.1.1.1.5. With this, the configuration on router 4 is complete. Is configuration needed on router 5? It's not necessary. So if we have configured routers 1, 2, 3, and 4, can router 21 access it during this process? You can take a guess. Now we can take router 21 and try again, ping 5.5.5.5. Can it ping successfully? If it's under the configuration view, we need to add a do before pinging, like do, ping 5.5.5.5. Let's see if it can ping successfully at this point. It is also not feasible in this process. So why do we say it's not feasible? Because for data, if we want to communicate, it always involves a back and forth, meaning my data can go over and the other party needs to respond to me. Now, if the other party responds to me, I assume it goes out through this 1.2.0.016 interface, but then A5 needs to check, hey, do I recognize this 1.2.0.016? At this point in the process, we can look into A5's routing table to check. Now, during this process, we can use show IP route to check. At this particular point in the process, it is abundantly clear that it does not recognize or identify our 1.2.0.0 or 16 network. Therefore, in a similar manner, we need to carefully enter its configuration view and meticulously configure our static IP address during this entire process. We need to configure a static route for the IP route 1.2.0.0 set 16 network, so that future access is directed to 25.25.25.0, which is its subnet mask. The next hop can be set to our 3 or 4. Now, in this context, if we set it to our 3, it would be 35.1.1.3. Besides this, we can also choose to hand it over to 4, which would be 45.0.0.4. Apart from this, we also need to check if there are routes on 3 and 4. Otherwise, it's easy for the data to get lost when transmitted to 3 and 4. Now, during this process, we can use do show IP route to check. If during this process we notice that 3 does not recognize it, it might not be a problem. I can make it recognize it through static routing. IP route 12.0.0.255.255.255.0. Then we send it to our 2, which means sending it to 23.0.0.2. Similarly, during this process, we also need to make the corresponding configuration on 4. If during this process, we can use right-click to paste, then we select 4, and after right-clicking to paste, we send it to our 224.0.0.2. In this process, 2 does not need to have a route because 2 knows where 12.0.0.0 is, as it is directly connected. Ship. Now let's try using 1 to ping and see. In this process, similarly, do ping 5.5.5.5, and we can see that now. 5 exclamation marks prove that the ping was successful. In this process, this is our static routing, where there must be a route both ways. In this context, we need to configure numerous IP values on each device. Moreover, if between 3 and 5, let's say this link breaks, then unfortunately it cannot automatically switch from below. You have to manually specify it, manually assign the route, and in case of an incident, it cannot switch by itself. In this process, if it's within a large enterprise, communicating becomes very troublesome, so we generally use dynamic routing protocols. Dynamic routing protocols can automatically switch and recognize, hey, a remote fault. During this process, they can also calculate routes on their own. If it's Cisco, it will have dynamic routing like EIGRP. In most enterprises, OSPF is generally used. If anyone is interested in Cisco or network technology, you can leave a comment under our video for technical exchange or send me a private message.